Okay, so we really have two remaining things to talk about in terms of syntax before we start talking about architecture and how to put applications together, sort of more complicated applications than the one that we've been talking about. And one of those two topics is LINQ. So LINQ is essentially a way that you can use a query language to go through a list in C#. And what it does is it gives you a lot of the same functionality that a full query language like SQL would give you, but you can operate on things in memory instead of things in a persisted table somewhere. So LINQ itself stands for Language Integrated Query, and conceptually it's exactly the same as something like SQL or MySQL. And the long and short of it is that it provides you the same functionality, but you don't have to write all of the information to disk in order to use it. So LINQ allows you to work within compiled code on things that are held only in memory. So the most obvious use for something like this is filtering a list or sorting a list or searching through a list for a specific item. But combining lambda expressions with LINQ, you can essentially do 90+% of any programming task you can possibly imagine without standard C# syntax. And the reason is that almost any kind of non-trivial programming task you want to do is going to have some sort of list in it. You can make that task list-oriented, and then you can use the LINQ in order to access elements of that list and do things like assign values to variables inside of a list, do aggregations, all that kind of stuff. So what I want to do really quick is I want to walk through some kind of empirical examples of how to use LINQ and when to use LINQ and what LINQ looks like. And then what we're going to do is we're going to swap over to the last kind of topic that we need to talk about. And as we go through the end of the semester, what we're going to do is we're going to end up seeing LINQ all over the frickin' place. And a lot of that will kind of reinforce what you're seeing right now. I just wanted you to be introduced to what the syntax is and the concept of LINQ so that when you see it, it's not some sort of mysterious magical thing. So here what we have is I have set up a list, and that list contains simply the first 10 integers, so 1 through 10. If I wanted to only grab the evens from this, what I could do is use the from keyword and say from my list, so from some number, so this is a working variable, sort of like the I in a for loop. So from num in first 10, where the number modulo 2 is 0, I want to select that value. So what this is doing is kind of going through the list. It's evaluating each item in the list using modulo 2, and then it's saying if the modulo 2 of that number is 0, then put it into a temporary list, and that temporary list becomes the value evens. And so this bar, what you're ultimately going to get is an IEnumerable of integer, and that IEnumerable of integer will be the even values inside of this list. You can also do something like getting the evens in reverse order. So here the only thing that we've done is we've added this order by clause, and so here what we're doing is we are ordering by num descending. And so by default, it will order by ascending. So if you just say order by num, it should order by ascending order. Descending flips the order, essentially. You can also do something like dynamically generate error messages or dynamically generate menu values. So you've seen the coding pattern over and over and over again in the programming assignments about generating a menu with an index at the beginning of the menu so that a person can actually choose an item. So you could absolutely use LINQ in order to generate those dynamically. So what you're doing here is instead of selecting the number, we are selecting some string that interpolates the number into some other literal. So here what we're going to get is we're going to get a series of strings that series of strings is going to be number, colon, space, and then that number. So you could use this exact same concept to iterate through a list of, say, products, and then you could format the string however you want, selecting only the products that meet some criteria. And so I'll actually use this in my walkthrough of programming assignment number 2, my code, to show that you can actually use this to differentiate the product by weight and product by quantity products. Other things you could do are aggregate values. So this is a little bit of list API stuff and a little bit of LINQ. So you can combine LINQ to get, or you can use LINQ to get some list, and then you can use the list API to get either the sum or the average or the count of values in that list. And so if you wanted to get the total sum of evens, you would just get the evens using LINQ, and then you would use the sum method on the list, or the IEnumerable. You do the same thing for average, you do the same thing for count. So these things end up being very, very useful. If you're trying to calculate something like subtotals or whatever, many of you have already found these and used them. But going back to programming assignment number 2, if I wanted to show you the sum of all of the product by quantity or product by weight in my shopping cart, I could do that by using LINQ first to get only those that are actually product by quantity, and then summing the values of the price of each of those things. So we're going to talk about SQL in a couple of weeks when we actually talk about persistence and kind of how persistence fits into the larger scheme of things. So right now what we're talking about is C# and kind of wrapping our mind around the programming language itself, what the programming language allows us to do kind of programmatically. But as we march through actually building web applications, we're going to have to store our information somewhere. And so in programming assignment number 2, we kind of had rudimentary persistence, which was basically a file that had a bunch of JSON blobs. We're going to grow that up into a full database. And when we do that, we're going to start looking at SQL as this kind of way of building queries against persisted data, so that you can run reports, or you can understand kind of what you have in persistence. You can also do things like ID synchronization in SQL, which we're going to talk about. And you can do all sorts of stuff. So SQL ends up being a fully sort of full-fledged programming language. And what we want to do here is compare the LINQ syntax to SQL syntax. So what you'll find is that the LINQ syntax, when it was originally created, was supposed to be very, very similar to SQL, such that a person who knows SQL would be able to read a LINQ expression and understand what is going on. And so if you can come up with a query expression language in a managed language like C#, what you can do is you can start having people build horizontal skills. So because I have SQL, I now kind of implicitly understand LINQ, and so any C# that has a LINQ expression in it, I don't necessarily have to be trained on C# to read what the heck is going on. Unfortunately, this didn't necessarily carry through, right? So we do have a lot of the same keywords, we have a lot of the same ideas, but the select statement is at the bottom of the LINQ statement, whereas the select statement is at the top of the SQL statement. So essentially, LINQ and SQL are identical, except that the select comes at the end. The select comes at the end of the LINQ expression because of the way that the type system works. So essentially what's happening here is we are starting with a list. At the end, this select is actually using a method to pull specific items out of that list. And so if we start with the items, we can't have items without a list first. And so as you kind of put the syntax into how the language is arranged, you actually have to have the list first, because otherwise when you generate the intermediate code, you're referencing something that you haven't actually created or created a reference to yet. So the main difference between these two things is that the select is at the bottom of the LINQ, select is at the top of the SQL, but once we get to SQL, you'll see that essentially the components of these two types of queries are essentially the same. One of the things that is difficult for people who are first learning SQL to kind of wrap their head around is grouping. So you can imagine grouping as basically you have a whole bunch of data and you want to cluster or group that data based on a specific property of the data points. And so here what we have is we have data points that are students. And so this is a custom data type here. It has a name, it has a classification. So this is 1 for freshman, 2 for sophomore, 3 for junior, so on and so forth. And so it's a very common use case that you would have a list of custom data structures like this. And what you would want to do is you would want to provide something maybe on the dashboard of your website, or you want to do some rudimentary reporting or fill in some informational boxes in a screen somewhere. And you would want to aggregate your list based on classification. So instead of just saying, I have, 3, 4, 5, 6, 7, 8, 9, 10 students. I have 1, 2, 3 freshmen. I have 1, 2, 3, 4 juniors, 2 seniors. But we want to be able to do that with a list that isn't necessarily 10 students. We want to be able to do it with 300 or 3 million students. And so grouping in LINQ allows you to do that. So here what we're doing is we are taking all of the students and we are grouping them by the classification property of the student. So you can use this dot syntax in both the group and the order and the select statements. So let's say that you wanted to get only the classification of the students. You could actually do select student.classification, and that would give you a list or an IEnumerable of int instead of an IEnumerable of students. What we're doing is we're using the exact same idea here to group by not necessarily the student class itself, but we're grouping by only the classification property of that class. So what this does is it gives us a group kind of intermediary variable, and student groups is going to be an IEnumerable of that intermediary variable type. And so what we can do is we can get the key of that group, and so this will be 1 for freshmen, 2 for sophomores, so on and so forth. And then we can also count the elements in that group, or we can get the value of the group and actually go through the cluster or the group of students and pull out their names, so on and so forth. So what this is doing is it's essentially allowing you to aggregate sublists of the larger list of students, and then you can really do whatever you want to with them. This thing is essentially a key value pair that has additional functionality wrapped around it. So here we see we have 3 freshmen, 1 sophomore, 4 juniors, and 2 seniors. So the other thing that we want to cover along with LINQ is the concept of a lambda expression. So a lambda expression, you'll see them all over the place in the last half of the class, and it's essentially an equal sign and then the greater than symbol. What happens is all of the enumerable lists in the C# kind of ecosystem and really the .NET ecosystem, they expose an interface where you can actually invoke LINQ using lambdas in a different API. So the API that we're talking about now, instead of using LINQ syntax, uses dot syntax to do exactly the same things that we were looking at previously with LINQ. So the way that this works is you pass a lambda expression into those methods, and those methods allow you to do things like order by specific properties, or select specific properties, or filter based on specific properties, and you don't have to remember LINQ expression syntax. You can only remember what the method names are, and then the LINQ expressions will look much more similar to kind of standard C# syntax. So some examples are list.first, first or default, any, where, for each. And we've gone through a lot of these. We talked about these two before when we were talking about null reference exceptions. Any essentially just returns if there are any elements in the list that match some criteria that's passed in as a lambda expression. Where passes back what sublist matches that search expression. For each iterates through the list and does something that you pass in as a lambda expression. So an example here is if I have a list of students and I want to find all of the students or the first student whose name starts with Laura, whose name is Laura. We can do either of these two things. So either we could look for the first one. If this doesn't have an answer, this will throw an exception. First or default will actually send you back a null student, so a blank student, if it doesn't find Laura. But this inside of here is the lambda expression syntax we're talking about. So on the left-hand side of the lambda expression, you have a temporary variable. In the right-hand side, you have the temporary variable being used to dictate what you want the filter value to be. And so here we know that S is a student, and we want to match all students whose name equals Laura, and we're using the standard sort of string comparison that we saw in a lot of the code alongs so far. So here, what we're doing is we're using any to figure out if there are any items in the list at all. This is the same as checking .count is greater than 0. This happens to be a little bit faster. So here we're essentially just looking for any elements at all. Down here, we're looking for elements that meet a specific criteria. So again, we have this temporary variable, and in this case, we're looking for any students where that student has a classification equal to 1. Here, what we're doing is we are getting a sublist of students that contain students where the student classification is 1. So where essentially gets a sublist of your list. At maximum, obviously the where would just return the entire student list, or it would return an empty list. This is the part where you can actually start doing a lot of C# functionality inside of this LINQ API that we were talking about at the beginning of the lecture. So here, what we're doing is we are getting all of the students, and we are grouping those students by classification. Here, what we are doing is we're going over each of the items in that list of student groups. So this is, again, that key value pair. And what we're doing is we are calculating the total number of students by going over the list of groups and then adding the students that belong to each group. So we're essentially saying that the total number of students is the number of freshmen plus the number of sophomores plus the number of juniors plus the number of seniors. But this illustrates what you can do in terms of actually assigning values. So here, after this for each is done, our total students will actually reflect the total number of students in the aggregated group list. LINQ is a nice thing because the Microsoft SQL Server query optimizer is a thing that has been worked on ad nauseum by Microsoft for decades. It goes all the way back to like a mid-90s implementation of how do I run queries on B trees and have those queries be really fast. LINQ steals a lot of the same optimization concepts. So even though LINQ feels very much like this sort of addendum API, it has very, very, very good performance. So if you were to try to build an algorithm that does something like iterate through a list of complex types and pull out a sublist that meets specific criteria, it's very likely that the LINQ where API call would be able to do the same job much faster. If you have something really, really complicated, potentially you could find a better algorithm for finding the sublist or for computing whatever aggregation you need. However, in that case, almost all the time, your types are too large, or you have drawn your class boundaries incorrectly somewhere, and so the queries being slow are less an artifact of LINQ being slow and more an artifact of architectural debt somewhere in your program. The nice thing about LINQ is that, especially with the API, the code itself is really, really terse, but it's also really easy to follow. So anybody who has read extremely idiomatic Python will definitely tell you that idiomatic Python is great if you understand idiomatic Python. If you have only read Python for maybe a couple of days, if you're brand new to the language and you read a bunch of idiomatic Python, it seems like witchcraft. LINQ has a lot of the same witchcraft tendencies. It allows you to do a lot of crazy things that you wouldn't necessarily associate with a query language, but at the same time, it's all very sort of self-documenting. So because you have access to the method API that uses standard dot syntax, there's very little mystery as to what LINQ expressions are doing with lists. The absolute best part about LINQ is that you don't have to rely on writing very large loops. So if you have gone through programming assignment 1 or programming assignment 2, at this point you have probably nested several loops inside of each other. And so from a complexity perspective and kind of a defect prediction perspective, trying to nest loops, especially when you start adding conditional statements inside of the business logic inside of the loops, the cyclomatic complexity of your code is very high very quickly. And so what LINQ allows you to do is have the same complexity of code, but have fewer bugs because there's actually less code to actually make a mistake in. So this is, again, a very rare situation in software engineering where your code is both terse and also really easy for somebody who didn't write it to follow. So that is a very brief introduction to LINQ. And so as we go through the rest of the class, we're going to start building server-side headless APIs. Those APIs are very likely to return lists. And so it's important that we can use LINQ to modify those lists on the server, where we expect there to be many more resources than a user's phone, for example, and pass back only the information that the user requests. And so LINQ is a very, very key, very easy way of meeting that requirement. So you don't necessarily have to understand LINQ from top to bottom. You should, at the end of this, know that LINQ exists and why it exists. And as we see examples of LINQ in code walkthroughs and that kind of thing, I'll point them out. And you'll pick up very early on kind of the usefulness of LINQ as a concept for C# programming. So thanks very much for tuning in, and I will see you in the next video where we'll talk about how to send and receive information over a web call.